Hello, and welcome to this tutorial for BioXTAS RAW. In this tutorial, you will learn how to do molecular weight analysis in RAW. This tutorial assumes that you've already done two previous tutorials, the tutorial for loading, averaging, and subtracting data, and the tutorial for doing the Guinier fit. If you haven't done those tutorials, please do them now. If you have done those tutorials, you should see a screen in RAW like this. On the left, you see the subtracted scattering profiles for glucose isomerase and for lysozyme. If I click on one of them, you'll see it highlights in blue, and you can see the Guinier fit information in the information panel. It's important to have this because molecular weight methods for SAXS require usually either I of 0, the radius of gyration, or both, and we get these from the Guinier fit. That means you need to do the Guinier fit before you do the molecular weight analysis. Once we're ready to do the molecular weight analysis, you click on the item to select it, it's in blue, and then you click on the molecular weight button here. This opens the molecular weight panel. RAW natively supports 4 methods for doing molecular weight. These are the 4 here: I of 0 reference, absolute scaling, volume of correlation, and the corrected Perot volume. Additionally, if you have ATSAS installed, RAW will display 2 molecular weight methods from that package. This is the Bayesian inference molecular weight in DAT-MW, and the shape and size molecular weight implemented by DAT class. These 2 methods here, the I of 0 reference and the absolute molecular weight, depend on knowing the concentration. So in this case, I measured the concentration before measuring the sample, and I know that the concentration is 0.47 mg per mil. If I go ahead and enter that, you can see the molecular weight is calculated for both methods. It doesn't matter which box you enter the concentration in. The other thing I want to note is you can see the Guinier parameters here. I of 0 and RG. If you open the molecular weight window without having done the Guinier fit, you can click on the Guinier fit button, it'll open the Guinier window, make that calculation, and then return to the molecular weight window and you'll see the molecular weights. So the I of 0 reference and the absolute scaling depend on having a configuration, an accurate configuration loaded into RAW. The I of 0 reference needs to know what the reference file is and what its molecular weight and concentration in I of 0 were. The absolute scaling needs to know that you're on the absolute scale. This should be done at the beamline where you collect the data, or you can do it yourself by changing the advanced options in RAW. Either way, you do need to have this constant accurate calibration loaded in for these methods. The other 4 methods should show a result regardless of what calibration you have loaded in. Once you've opened the window, you've entered the concentration if you know it. The other thing you should do is you should look at the details for some of these methods. So all of them, if you click Show Details, will show information specific to the method. So the I of 0, for example, shows information about what the reference file is and what its values were. The absolute intensity shows reference for calculating the absolute scale, the calibration parameters you need. Most importantly, though, to check is the volume of correlation. So this depends on an integral of q times I of q, and that integral needs to have come to a constant value at some point in order to get an accurate estimate out of this version of the molecular weight calculation. So if you click Show Details, and then you scroll down, you can actually see a plot of the integral value versus the q vector, and you can see for this particular data set, it's come to a nice plateau out here at high q, which means that we should get an accurate value for the volume of correlation within the limitations of the method. For the Perot volume and for the volume of correlation, both of them actually have a Q cutoff that gets applied to the data, which you can check and change here. This is because they make some assumptions. For example, the Perot volume assumes that the intensity decays as Q to the minus 4 at high Q. This ignores internal structure of the macromolecule, and so you have to cut off your integral of this data set at some point before that starts becoming important. I'm going to hide the details here. If you show the details for the Bayesian method, it'll show you the calculated Bayesian probability for the molecular weight and for the probability that the molecular weight is inside the given confidence interval. If you show the details for the shape and size method, it'll show the DAT class shape category and the DAT class estimated Dmax. The other important thing to check is the More Information button. So if you want to know more about the molecular weight, if you click More Info, it'll show you a brief description of the molecular weight, a little bit about when it's useful and when it isn't, and most importantly perhaps is that it'll have the appropriate citation for the method. So if you're using these methods in your calculations and your data, if you're then going on to report it in the publication, please check either this More Info or check the RAW website and make sure you get the accurate citation for the method. Once you've calculated a molecular weight to your satisfaction, you can go ahead and click OK. Like the Guinier fit, that saves the molecular weight information with the scattering profile. You can see it's now filled out in the information panel with all the different methods. And if I click on this triangle here, it'll show more details about the molecular weight calculation for each method. Now, we can do the same thing for lysozyme. You can access the molecular weight window by right-clicking and selecting molecular weight. I know the concentration for this one is 4.27, so I'm going to go ahead and enter that. You can see in this case, the shape and size approach did not calculate a molecular weight. That's because the scattering profile wasn't measured out to high enough Q given the RG of the molecule. If you're not happy with the molecular weight, if you don't want to save the results with the scattering profile, you can click Cancel. In that case, you can see that the molecular weight doesn't get filled in on the information panel. I'm going to go ahead and reopen the molecular weight window. I'm going to enter the concentration. I'm going to click OK. And you can see now the molecular weight estimates are filled out in the window. RAW remembers what values you enter for the molecular weight, calibration parameters, and the concentration. So if I reopen the window for lysozyme, you can see, for example, that the concentration is filled out here. With that, that's the end of this tutorial. You should now know how to calculate molecular weight in RAW.